Hello. In this session, we are going to discuss about the unsupervised learning. So far, we know about the supervised learning. Whatever we've been discussing so far is supervised learning. What is the difference in between supervised learning and unsupervised learning? Let us understand. In the supervised learning, when we collect some data set, the data will be labeled. For an example, I'm going to design a model, prepare a model, which is going to identify the given image and classify it into either dog or cat. But for that, a model should be adequately trained by feeding the necessary numbers, the huge number of dogs and cats images. Right then, right after this training is adequate training is provided, the model will be able to perform the intended task, that is taking the given image and classify into dog or a cat, right? That is supervised. In supervised learning, there's a label dog, there's a label cat. When an image is provided during the training, that is already labeled. But here in the unsupervised learning, there will be no labeled data at all. The data points are completely non-labeled or unlabeled. There is no label provided to any data point. A data point is completely raw. For an example, we do have images and there are no groups of the images. We don't know which image is the dog, which image is the cat. In unsupervised learning, model itself should draw the patterns, should extract the patterns through which the model will be able to perform the intended task. This is unsupervised learning in a nutshell. Now, key characteristics of unsupervised learning, as we discussed, no labeled data, as we discussed. It is going to must find the patterns and the structure in the data without explicit instructions. There are no labeled data. Next thing is a pattern discovery. It is going to identify the patterns. The algorithm tries to find a hidden structure in the data, such as grouping the similar data points. Initially, we just need to cluster. We need to identify the similar objects and group it together. For an example, all those has a tail will be grouped into an animal. Okay, and reducing the dimensionality of the data. Of course, dimensionality reduction is the key aspect of both supervised and unsupervised learning here, in which we're going to remove some unnecessary data. Detecting anomalies or outliers within the data here. Anomalies meaning what? Anomalies are the data points which are misfit. For example, there are outliers. Outliers are not going to contribute, rather data is and the model is going to underperform. Similarly, anomalies. For example, I just wanted to only classify the given image into dog or a cat. Here, donkey is irrelevant, right? So we should be able to identify the anomalies as we already did for the supervised learning. The types of unsupervised learning will be starting with the clustering. What is the clustering? Clustering meaning, first of all, all the given data points should be grouped together. This is called a clustering. To perform clustering, we can have k-means or DV scan or hierarchical clustering. Okay, and right then we will go for the dimensionality reduction. In the dimensionality reduction, as we discussed, we are going to reduce the dimensionality of the data. The techniques to do this is PCA, principal component analysis. Regarding this, we already discussed in the second unit. Just go through the second unit. TSME and auto encoders. TSME also we discussed. Okay, anomaly detection. As I explained you already, anomaly detection is another key aspect of unsupervised learning, in which we just are going to identify the irrelevant data. Anomaly detection is pretty useful in fraud detection or network security. The applications of unsupervised learning is a customer segmentation based on the interest of the customer, based on the pre-purchasing, the pre-purchasing history of the customer's purchase. Customers will be suggested with the right products. Right customer will be given with the right advice to buy a product. Recommendation systems such as YouTube or Instagram is going to suggest only the relevant videos to the relevant customers. Okay. And the next thing is data compression. For the data compression, also we will use this anomaly detection. Also we'll use unsupervised learning. Okay. Right then, we're going to discuss about the elbow method. Now here, why do we need to have this elbow method? Understand carefully. See, when we are provided with the data set, when we collect some data points, we know that there are no labels at all. When there are no labels, obviously there are no groups. There are no groups. First of all, we are provided the raw data set. There are several, let us say, 1,000 images. Since each image is not labeled, we actually don't know there how many clusters are available. We don't know what is the number of clusters even. For an example, in the given 1,000 images, there may be 20 groups of different animals, but we don't know that detail before the hand. So initially, what we need to do is before we group them together, first of all, we should be able to identify the number of clusters. We should be able to identify the number of categories there. For that, we will use the k-means, elbow algorithm, the elbow method. This elbow method is used to identify the number of clusters. It's going to find out the optimal number of clusters. Okay. So initially, what we'll do is, in elbow method, initially, we are going to fit k-means for different values of k. Anyhow, we're going to discuss about the k-means. Okay, what we'll take, we'll data point into the k-means. This k-means is going to give you, starting by fitting the k-means algorithm to the data for the range of k values. Okay, 1 to 10, k value will be just generally in between 1 to 10 or higher. Okay, for each data point, we are going to compute the sum of the square distances. Let us say there is a center of the cluster. There is an identified or an imagined center of a cluster. This is the data point. Now I have a data point k. This is the distance d. We are going to identify the sum of the square distances. Okay, this is the distance. This is the square. Okay, sum of all the square distances between the data points is called an inertia. That is going to be computed here. Then we're going to plot the inertia values against the number of clusters. Okay, against the number of identified clusters, we're going to plot the inertia value. Then we are going to find out the elbow. Initially, what happens is the point the inertia starts decreasing at a slower rate. Initially, inertia moves at a faster rate, but there will be some point at which inertia decrease at a slower rate. This becomes your elbow. Is considered optimal. This is the total optimal number of clusters. Okay. Okay, this is sample code for, it's a simple and sample code for identifying number of clusters of k-means. That's it for the session. Thank you.